Hello everyone, in this video we'll go through types of variation. So in statistical process control, we divide variation into two different categories: random variation and assignable variation. So the random variation, also known as common variation, so it is the natural variation in your process which cannot be eliminated without process re-engineering or by redesigning the process. So in day-to-day activities, you will observe lots of random variation in different processes. A very good example here is the blueberry muffins in a bakery. So whenever you buy the muffins next time, just weight them individually. You will see there's a slight variation in the weight of each muffin. Similarly, the number of blueberries, number of chocolate chips from muffin to muffin may vary. So there are countless of factors which can cause random variations, such as labor skills, workers' experience, machinery, like old machines will have more variability, right? The second type of variation is assignable variation. As the name stands, that we can assign this variation to a specific cause. So when you can assign variation to a specific cause, we can easily eliminate it by going through statistical process control or using PDCA cycle or the continuous improvement procedures. So going back to the blueberry muffin example, if you have a muffin missing from the packaging, so that is a assignable cause variation. Similarly, let's say the label is misprinted. You have a packaging saying blueberry muffins, but you have chocolate chip muffins packaged in that. That's assignable cause variation. So this could be due to the human error, due to misprinting of labels, and so on. So we can assign it to a specific cause. Let's use two more examples to fully understand this concept. Let's say you start your work 9 a.m. every day. So to simplify this, let's say you leave every day at 8:30 and you use your car to go to work. On your way to work, let's say there are four traffic lights. So every day you reach at your work, it's going to slightly vary depending upon how many traffic lights were red, right? So someday if you find all traffic lights green, you may reach in, let's say, 18 minutes. But if the all traffic lights were red, you may reach in 22 minutes. So you kick off at 8:30 every day, but it takes you from 18 to 22 minutes to reach your work. However, on a given day, let's say there was a accident. So due to accident, you need to use a different route to reach your work, which took you 35 minutes. So this is an example of assignable cause variation. So now you can think of more examples as you from your day-to-day life, and you should be able to kind of link it to random cause and assignable cause variations. Okay, so the next question is how we are going to differentiate between random cause and the assignable cause variation, especially when it comes to process control, right? So for that, we use control charts. So that is what we're going to do in this chapter, chapter 10, to develop control charts in order to identify if there's a random or assignable cause variation. So let's look quickly into control charts. So the control chart is also called a run chart, which is used to monitor the process in order to distinguish between random and assignable cause variation. The control limits are set to plus minus 2 or plus minus 3 standard deviation. So how to read control charts? I'm just going to introduce the terminology here so that you guys are familiar when it comes to numericals. So when you develop a control chart, you are going to have a mean value, which is the process mean, upper control limit, which is calculated through process mean. So I want to say process mean, let's say mu plus 3 sigma standard deviation, right? So this is just an example based on 3 sigma. Lower control limit is going to be mu minus 3 sigma, right? So the point I'm trying to make here is the upper control limit is the larger value than mean, lower control limit is the smaller value than mean, right? So once you have identified the control limits and the process mean, then you collect data or a sample of different observations, right? So in this case, if we look at observation number 1 to observation number 11, we can say these all values are within the control limits, within upper and lower control limit. These are varying around the mean value, right? So there's still some variation. We don't have a straight line here, right? So this is due to random cause variation or the common cause variation. And when you have a common cause variation in a process and the values or the observations are both sides of the mean value, we will say the process is under control. However, when you have an observation which is outside either upper control limit, or let's say there was observation number 13, or outside the lower control limit, this is due to special cause variation. And when there's a special cause variation, the process is out of control, and the action must be taken to bring process back in control. So again, just to reinforce this point, if you have observation within the control limits, the process is in control, and this is due to the random cause variation. However, if you have an observation outside the control limits, this is due to the assignable cause variation or the special cause variation. So that's how you will use control charts to differentiate between random and the special cause variation. If you still have questions, please feel free to ask. During the live session, we will discuss how to develop control charts using R charts and bar charts. Thank you.